Let's learn about the collision theory and how it relates to chemical reactions. Roll the graphic. Hi, I'm Paul, this is Science That Sticks. Let's look at the collision theory and how this relates to a chemical reaction. In the laboratory, at school, or even just cooking or whatever, you will have seen chemical reactions. A chemical change involves two things reacting, or one thing reacting, and some new substance is created. Now, that new substance might be an element, that new substance might be a compound, but it's not easily changed back into the original components. It's the first major important thing to know about a chemical reaction. Well, how does it happen? Well, because all particles and all atoms are moving, even if it's just vibrating around a spot in the case of solids, many particles are able to move freely, such as in liquids or in gases. When they move freely, they can bump into one another. If they bump into each other with sufficient energy to break the bonds that they are in and form new ones with other atoms, then we've got a chemical reaction. So a chemical reaction is when a successful collision takes place where there's been sufficient energy to break bonds and build new ones. Let's draw this very quickly behind me. I've got reactant A and reactant B. Because they're moving around, now I'm going to assume that they're going to be a gas because it makes things easier for you to concentrate and think about. As they're moving around, they can bump into one another, but there might not be enough energy. We might need to just push them over the edge of that energy barrier, the activation energy, to make them collide successfully. Remember, a successful collision has enough energy to break the bonds and create new ones. Now, you can imagine these bonds as being covalent or ionic, it doesn't matter, or even metallic. What matters is that the bond itself is broken in a chemical reaction. Now, if this is moving, it can collide with that, and this could also collide with this. As it does so, the bonds might be broken, and you end up with four separate particles just for a fraction of a second. But for GCSE, we don't tend to talk about that. So let's assume that they are kind of broken apart, but really quickly, like in the same instance that they break apart, they actually reform as a new product. So if we've got A and B and we've got some new product C, we could write this as a chemical reaction. So A plus B gives us C. In this case, we've got one molecule of A, one molecule of B, and we make two molecules of C. We can have it like that if we so desire. But here's not really the point for getting bogged down in equations. Here is what the hell is happening. Well, this bumps into this, hits it with sufficient energy that bonds are broken, new bonds are being formed. Can we speed this up? Absolutely. We warm it up, we heat it up. By adding heat, the particles move faster. As they move faster, more chances of a successful collision. If you want to slow it down, you cool it. Less movement, less kinetic energy, less chance of a successful collision. What else could you do? Well, you could add way more of them. You could increase the concentration. But if it's a gas, you could increase the pressure. By increasing the concentration or increasing the pressure, you increase the chances of a successful collision. And vice versa. If you decrease the concentration, decrease the pressure, the chances will be lower of a successful collision. Pretty easy stuff. What else could we do? Well, we could introduce a catalyst. A catalyst simply lowers the activation energy, allowing more particles to have sufficient energy with which to begin the reaction. That's it. Everything in terms of chemical reactions is based on this premise and this idea. If you want to get good at rates of reaction, you've got to know about the collision theory and what factors affect the speed of the reaction. And I'll go through them again. They are the temperature, the concentration, the pressure. Actually, surface area, I've not talked about that, but surface area, if you've got a solid, instead of it being in a big cube, you grind it into dust. Bigger surface area, more sites for the reaction to take place at, more successful collisions. Vice versa, you could also reduce all of those and slow the reaction down. You could also use a catalyst. That would increase the rate of the reaction, but it provides a lower activation energy. Remember, activation energy is the minimum amount of energy required in which the reaction can actually start. That's it. Learn it, take notes, then do some questions. Until next time, as always, stay cool. Bye bye.